All right, hello everyone, and welcome to the Convex Community Call. So we're live with a few people from the Convex Discord who are joining the conversation today. So it's the first time that we're trying this particular configuration. Um, if anyone wants to join the conversation, then feel free to come in and join the community call on the Convex Discord. Otherwise, all very welcome to listen in on YouTube. We'll have the YouTube chat as well. So if any chat messages come through, I'll be keeping an eye on those so that we can take people's questions and any thoughts or ideas from there. So welcome once again, everyone. So the topic for today is data, AI, and crypto, which I think is a super topic. It's convergence of three of the most interesting spaces in technology right now, and really just to explore what people have seen, what people are interested in, what people are excited about, and also what some of the opportunities in this space are, and with specific reference obviously to the Convex ecosystem and the sort of the work that's going on here. So full disclosure, we do have a couple of startups in stealth mode using Convex who are in the sort of general AI space. So hopefully we will see some exciting announcements in that space soon. But hopefully we can have quite an open conversation, just talk about various different ideas and experiences, and what some of the exciting big ideas and opportunities are. With me on the stage, we've got Rich and Quarkside, who have been a long time thought leaders and key team members on the Convex project, who both bring a wealth of experience from different industries and various startups in the AI and crypto space.
Hey, Mike, how are you?
Very well, thank you. Yourself?
Good, good. Yeah, I'm pretty excited about this topic.
Yeah, I mean, why are you excited? I mean, you suggested it. So, what was the things going through your mind?
Well, I think that there's a big opportunity for Convex to leverage in the AI space. Clearly, with your background and the way you got started with Convex, and why you started thinking about Convex was really about the data side. And, there's so many bits and bobs that need to be pulled together to really make AI provenance and so forth secure and traceable. And we don't see that right now because everything is centralized.
Yeah, and I think this is going to be. I think it's going to be one of the key topics for today, isn't it? That a lot of data and AI work currently is massively centralized. It's happening in the big tech companies. Your Google, your Facebook, your Amazon, and I think there's a very open question about how much of that is likely to be decentralized and what parts of it are decentralized. And I think that's where a lot of the interesting intersections will come. Is which bits of that really make sense to be done in a truly decentralized way. So timely conversation. Now I did have some experience. So I was formerly a CTO in the Ocean Protocol group, and that was looking at the intersection of data, AI, and crypto. And had its own angle on that, which was more around the tokenization of data assets. I mean, I think the broader problem is actually much more interesting than that, in the sense that AI is increasingly becoming a complete. It's not just about a data asset, a data set. It's becoming about a complete supply chain. Yeah, from sourcing the underlying raw data, which is going to be used for training or for testing or for actually usage in various applications. It's the data cleaning, it's the transformations and the joining of data that need to happen to make it usable for different kinds of AI use cases. And it's obviously the application of the algorithms, the model training, and then deploying those models to various different, production usage, whether that's in a web service or whether that's on some kind of decentralized platform itself. And it's really a supply chain problem because different organizations have different pieces of the answer, and it'll probably never be the case that everything happens in one centralized domain. Yeah, so even like your big AI companies at the moment, they're all sourcing data from the internet, from thousands of individual creators, which is obviously a controversial topic in many ways. And
Yeah,
and
I see that there's some lawsuits going on, aren't there?
there's going to be huge lawsuits because a lot of people are very unhappy that all of the upside of their creative work is being captured by a few small, fairly concentrated companies, and that's kind of against the spirit of decentralization. That everyone's hard work gets appropriated and monetized by someone else. Doesn't really go with the spirit of saying everyone should be given a fair reward for what they contribute to the overall economy or the overall ecosystem. So
I saw that even Elon Musk is suing OpenAI because he feels like their original charter was to be more of a public good, and the account states that now Microsoft has control over it.
yeah,
And so
yeah.
that,
I mean, that's very interesting in itself. Yeah. So this some of this technology becoming closed source, I think he was upset about,
yeah,
and actually thought it
yeah.
should be open. And we're all about open economic systems, and if AI is going to be fair and everyone's going to be able to participate in a fair way, the ecosystems around and the economic systems built around AI are going to have to be they're going to have to be much more open. They're going to have to be much more decentralized, and that's where obviously the things like Convex come in providing a platform specifically designed for open economic systems. And I think the AI economy is definitely going to be one of those super important systems.
I agree. The reason I suggested this is because I'm pretty excited about data lattice, and there's a lot of data that's needed, but the storage aspect and the integration between the compute lattice and the data lattice is interesting to me because I think it brings a real big opportunity for Convex.
Yeah, I mean, because that's something that's kind of a bit unique for us, that we have the on-chain publicly verified aspect, which is the global state and the transactions and the consensus system, if you like, which is sort of at the core of what Convex provides. But most applications are never going to put the majority of the data on that kind of system. It doesn't make sense, whether that's for cost reason, economic reasons, whether that's for privacy reasons, or in the case of AI specifically, hardware. So you need very specialized hardware to run some of these larger AI models efficiently. And a decentralized network doesn't can't really guarantee the availability of a lot of specialized hardware, particularly if you're trying to build a decentralized network that anyone can run a peer, because those people aren't going to have that kind of hardware. So one of the things that we've really focused on is saying, okay, we're going to build a common data system that serves both the need of the on-chain publicly verified information, and also a much more flexible usage in a wide variety of off-chain applications. So you think about it's kind of like a hybrid decentralized model. The economic stuff probably wants to be on-chain, smart contracts, these kind of things, but the data sets, the actual models themselves, the execution of the models is almost certainly, I think, for the foreseeable future, going to be off-chain computations. But we've built a common data infrastructure which can serve both of those use cases, and I think that offers us the chance to make some kind of full stack AI economy solution. in a way that would be hard to do if it hadn't been designed like that from the start. And the data lattice is fantastic. It's incredibly scalable. You can scale it horizontally, basically infinitely. And of course, it's all cryptographically verified, so you've got all the authenticity and the provenance and the integrity checking that comes with that. So I think they're very attractive features.
It sounds like it's an opportunity for the community to contribute some bits and bobs that are needed to flesh out the whole system. You know, we have a couple of questions. One is on the YouTube, and the others here in this community call.
Okay, great. So what do we have? Let me just have a look. Oops. So on the chat I see in YouTube, how practical is it to list on a ledger authoritative data sources used for training? That's a really good question. So it depends on what you mean by an authoritative data source. So typically you might have a training data set which is pretty large. Yeah, these can be, you know, gigabytes, maybe terabytes, you know, maybe even petabytes of scale. And you could theoretically build a big Merkle tree of all of that data, a file system or a repository of that data, and compute that all as a Merkle tree, hash it all up to a single 256-bit value, and put that 256 bit or 32-byte hash on chain, which would enable you to go back at any time and then verify this was precisely the data that was used for training. So in that sense, it is quite practical. If you wanted to use it to sort of provide integrity checking and provenance of some large data set. Now, would you want to do that for every data set? Not entirely clear. I mean, probably you might do it for some very important ones, or for some models, perhaps, where you wanted to an important version of a model where you wanted to reference what data that had been trained with. Would you want to put on chain a list of every single data set you ever use, given that you might be creating lots of temporary data sets for testing or development work or synthetic data sets? You're probably not going to put all of those assets on chain. You'd only probably want to do it for the ones that you really want to stamp as official versions and have provenance checking. I'll give an example. If there was some sort of regulatory requirement to be able to prove what data you used for training a particular model, which might be a regulatory requirement or it might be a legal requirement, then you might want to do that, because that will be a very good way of providing that authoritative provenance of that data. But you probably wouldn't want to do that for little mini data sets you're creating while you're doing experimental data science or exploring data sets or trying out different feature detectors, this kind of stuff, because, you know, that's just local stuff. Yeah, there's no need to make any sort of public statement around any of that. So that's how I think I would approach it. Yeah, you probably want to put some things are important and you would want to notarize them on chain. Other things are probably more sort of ephemeral, and you don't really need to do that. But, you know, great question, and I think it is likely to be increasingly important, particularly given the lawsuits and the regulatory focus on this, to be able to provide that kind of authoritative provenance. And, you know, we're in a perfect position to do that. The data lattice is exactly that. It takes big sets of data, you know, gigabytes, terabytes, petabytes of size even, and it gives you a single hash at the end of that that can be used to refer to and access and authenticate that data set. So that's a great data lattice use case. So you've got the data lattice storing all the data and doing all the heavy lifting, and the on-chain piece being used for cryptographic integrity, provenance, and you know, perhaps meeting regulatory requirements. So yeah, fantastic use case. That would be a brilliant project. Yeah, I could see a great startup just on that one idea. Yeah, how do you take the sort of convex data lattice and create authoritative provenance using these individual the hashes for key models, key data sets, and that could be a product. Yeah, I mean I think entirely feasible. I mean, we've basically got all the infrastructure there to do that already. It would just be a case of building the right product interface and APIs to that infrastructure. So yeah, I don't see anything stopping that from going ahead.
Yeah, I love that. That was what I was thinking. Is there's a pony in here somewhere, and it just needs to be uncovered. And I think there's just a few bits that are needed, right? You mentioned like an API interface and some front end interface. So, how can the community jump in and contribute to this kind of thing?
I mean, it really depends on what someone's skills and focus area are. Yeah. So if you're an enthusiastic hacker, I'd say just build it. Yeah. Just come in. The lattice components are basically there. They just need pulling together into some kind of module that does this sort of database management or data set management aspect, and then getting the single reference, and then there's probably a small smart contract to write that can notarize these hashes and provide some kind of governance or authenticity checks against those hashes. So that'd be a little smart contract. I could almost see like a Dropbox, or
Mm-hmm.
you know, or Git version control. Git actually does something very similar to the data lattice. So Git, for those who don't know, is a very widely used version control system. A large proportion of open source projects use it. Originally sort of developed with the Linux kernel in mind. And what it does is it just stores a big tree of hashes for each version of the software. So every time you make a change, every time you make a commit, every time a developer makes a code change, you create a new version of the software, and that gets a new tree with a new hash. And you can always validate the entire version of the software source code from a single hash. So it's very, very similar to data lattice, in fact. And you know, a lot of the sort of ideas from Git and the data lattice are very compatible. So
Does it store deltas or uh, the whole thing again?
I mean, it effectively stores deltas. I mean, it has
Okay.
an object database that kind of has all of the versions, individual components, but it's only the changed. It deduplicates. Yeah. So if you make one change to one file, and there's a million files, then your new version of the tree is going to have 999,999 files exactly the same, and then just one different
Right.
file. Yeah. Now Git is very tied to file systems. Yeah, because it was designed for source
Right.
code management. Yeah, so and source code management is all people do it on file systems and directories. The data lattice is a bit more flexible than that. So the data lattice isn't limited to file systems. You can use any kind of data structure. You can do JSON objects. You can do big binary blobs of data. You can do files. You can structure a file system on the data lattice. That's no problem. But it's got more data structures and more options, which might be useful for things like metadata. Yeah, so if you think about having more sophisticated metadata on individual
Right.
data assets, then the data lattice enables a lot of that kind of thing. So it's a bit more flexible than a file system, but you can use it to emulate a file system. So I'm sort of imagining a product which is kind of like a cross between Git and Dropbox. So you've got like a
Right.
file system browser. You say, here's my directory on disk. I would like to move that into the data lattice, and then it's like being on Dropbox. You've got like a decentralized Dropbox
Hmm.
kind of thing where it stores a copy of all of your files, but it deduplicates. Yeah, so if you change a single file, you don't store the whole thing again. You just store the deltas and stuff like that. And
Got it.
then that data lattice version would provide a hash, and that hash would be the sort of the authenticity route, which you can then put on chain. So we've got a question, Aman. Join the stage. Can you join the stage, Aman? Is that a hands up, or is that just a
Yeah.
waving icon?
All you have to do is hit the microphone, Aman.
Let me just click this. Request to speak. No request. Yeah, still getting used to this. There is a request to speak thing that pops up. If you do want a request to speak, just do it, and I'll click the button if it doesn't happen automatically. So yeah. So another question from chat. Could you make a simple demo of using the lattice? Yeah, I think we should do that actually, because I mean it's not super complicated. It's just this data structure which gets stored in the. So we have a custom database called Etch, which stores these trees of data, and we could easily do a quick demo just saying, okay, here's something stored in Etch that isn't on chain, yeah, and like edit some documents or something like that. So yeah, that's a relatively easy one. Could be a fun little project for anyone in the community who wants to like build a sort of data lattice editor or a data lattice viewer kind of component. So we could definitely do with one of those just to test and be able to demo some of these data lattice ideas. I want to emphasize something that is really, really important. And a lot of people forget this. Models, as in AI models, themselves are data. Yeah, they're big files, typically with lots of tensors, so big arrays of numbers, and with some metadata and some a little bit of extra information that just helps you to manage these tensors. But they're basically just data. Yeah, so the model itself can be on the lattice. Yeah, so you've got your data set and you've got your model, and you may have then a new set of data that you want to apply the model to, which can also be on the lattice. And then when you apply the model, you're going to get some results. Now the results also is just another data set. Yeah, that again can go on the lattice, and again you can hash it to get the sort of the truth of what that data contained. So what you actually get is this sort of graph of transformations. So you started with data set A, you applied model B, you got result set C out of it, you maybe put that through cleaning process D, that when produced a clean data set E, which then went into another model F, and then resulted in the final output G. And that's just obviously a simplified case. Yeah, you could have many branches and many different trees, and every one of those can be a asset identified on the data lattice. Hey, man.
Hey Mike, hey RK.
How you doing?
I'm doing good. How are you?
Pretty good, pretty good. You had a question?
Um, Actually, I don't have a question, but yeah, RK invited me to this community call, so yeah, just attending this call.
Okay, fantastic. Well, welcome,
Yeah.
welcome on board. And we do have these chats, conversations, and live streams pretty much every week, and try and talk about some of the interesting big ideas going on. So hopefully you find it interesting.
Cool, cool. Yeah, thank you.
Riley asked a question about whether AI computing uses a ridiculous amount of water. Riley, why don't you jump on and ask why? Why are you asking this question? All you have to do is raise your hand, and then Mike can hit the button and let you speak. Anyway, while he's figuring that out, Mike, we do dedupe and deltas also in the compute side, right, with the virtual machine. So it sounds like it's the exact same kind of architecture. Is that correct?
Yeah, exactly. So whenever you've got these big data sets or data assets, and you make a small change, but you still want to have access to both versions, then the only real way to do that efficiently is to deduplicate. Yeah, so if you've got a gigabyte data set and you change 10 bytes, you don't want to have to store another gigabyte data set just because 10 bytes are different. So you want a system that automatically deduplicates, and 99.999% of the data is going to be exactly the same, so there's no point storing it multiple times. So that's the principle we use in the data lattice in order to store different versions of data assets or other data structures successfully. It's also the same technology we use actually in convex, when the global state in convex can be quite big. So when people do transactions, the global state changes. So 99.999% of the global state is exactly the same. So we definitely don't want to copy the global state. It's a big data structure. So we only store the deltas and the differences. And there's some very cool data structures and algorithms that enable you to do that efficiently, which is one of the reasons why the CVM is so fast. But yeah, this idea of deduplicating is critical. It's also sometimes known as structural sharing. So you're sharing most of the data, you're only storing the bit which is different separately. Yeah, so you share the vast majority of the data, and that's the secret trick behind making these things efficient at scale. So another question. It's many years since we developed deep neural networks. How does it vary from modern AI algorithms? You know what? Neural networks haven't actually changed that much. The idea of an artificial neural network is pretty old. I think it's. I may be wrong, but I think it's about 60 or 70 years old. It was definitely the perceptron idea. Someone's probably got the exact time that the first perceptron paper was published. But the idea of having a mathematical network of mathematical operations that takes a bunch of inputs and produces an output, and you can train that network to give better outputs or closer to some kind of ideal outputs, has not changed. That is exactly the same idea from the original perceptron idea and the original ideas around back propagation, and that's still exactly what these models do today. Now, what has changed? So, first of all, a huge amounts of processing power, extra processing power, and hardware. Yeah, you can actually do things at a scale that would have been impossible 50 years ago. And that enables you to solve problems that you just couldn't have done just because of the hardware limitations. Second area that's been a massive change is data set size. The amount of data that you have determines often how well you can train a model to solve a particular problem, and access to the huge amounts of data that some of the modern internet companies have is sort of critical to that. So that's been a massive change. Thirdly, I'd say there are some innovations in architecture, how you structure the model. So a lot of the stuff around transformers, for example, GPTs, are about attention mechanisms, where you've got a special kind of structure that sort of creates like a little internal query, and it's all done with matrix mathematics, but it's basically like a little query that lets the model give more weight to certain aspects of the input data, and that turns out to be really useful. It helps these models to learn better, and a lot of research has gone into finding little innovations in the architecture, and those kind of things. So the architectural improvements, and then there's been some, what I would say probably like algorithmic tricks in training. So people have developed ideas like dropout. So the idea of dropout is you just turn off some activations or nodes in the network, and it turns out that randomly dropping out some nodes during training, again, improves your model. And we don't necessarily know quite why all of these things work, but there's been a lot of research and a lot of different initiatives gone testing these things out and finding better ways to train these models. But
Mike, it's been 80 plus years.
80 plus. There, I was out.
Yeah, perceptron was invented in 1943, according to Wikipedia.
Yeah.
But the first machine was built in 57.
Yeah, perceptron's an old idea. Perceptron's an old idea. I think the original perceptron, they didn't have back propagation.
Gotcha.
I think that might have come a bit later. So
interesting article in Wikipedia on it.
Excellent. I shall have to go and remind myself of the key dates. But yeah, the original the back propagation made a big difference. So back propagation was the idea that you could stack these things on top of each other and train it in a way that would actually train all of the layers simultaneously. So like with gradient descent and these kind of things. And that's still basically how we train networks today. Yeah, it's still a form of back propagation with a lot of tweaks and a lot of clever tricks to make it go faster. Because back propagation in various conditions doesn't work as well, or it goes very slowly, or these kind of things. But it's still essentially the same idea. Yeah. So a lot of it is just the scale and the capability that we've been able to throw at these problems now. Plus, obviously, some innovations in architecture. I think like transformer architectures are pretty interesting.
Inside the Discord, Yeller asked a question: does AI computing use a ridiculous amount of water? And he quoted an AP news article. This is the first I'm hearing that it's a water problem with AI.
I mean, it uses a lot of compute resource. Water directly, I mean, if you're water cooling, perhaps.
Yeah, that's what it seems to be saying, cooling down the semiconductors.
Yeah, I mean, you can use, but the thing is, water recycles. So coolant water, you're not really using that much water anyway. Yeah, the answer I think to that is no, unless you're thinking of something very very niche. But yeah, I mean, AI is just big beefy versions of GPUs. Yeah, I mean, one of the big breakthroughs was graphics processing units, GPUs, getting fast enough and scalable enough that you could use them for meaningful AI applications. And I've now got a graphics card in my computer that'll run 8 gigabytes, 10 gigabyte stable diffusion models, for example, for image generation. So it's pretty cool. That's running on my graphics card. Now, a while ago, you would have possibly need to buy some very expensive kit to run a model that size efficiently. But now consumer hardware is getting to the point where it can run these things. I don't know if anyone's been looking at the latest Convex desktop app, which is this lovely app here. All of these icons were ones that I did using Stable Diffusion. So just creating these images to illustrate different different tools in the desktop app. So that's just done on a graphics card. Yeah, and it would have been I know these aren't the most fancy. They're just iconic. Yeah, but it's not the most fancy AI art. But even that would have been unbelievable 10 years ago. So this space is just moving incredibly fast in terms of what's becoming possible.
So assuming that you were able to have a whole bunch of really good data and models, large language models on a data lattice, and it was the provenance was secured by hashes, what would the use model look like? How would people actually use that? You mentioned file systems and multiple kinds of file systems. What would be the best kind of architecture to pull off an AI version of a convex super app?
Good question. I mean, it's here's what you might have. Yeah, you might have an app that says, okay, here's a marketplace of different models. Yeah, you've got and these models are all notarized. You've got the hash on chain, who provides them, who offers them for download and use, etc. You can buy these. Some might be free, some might charge a license fee, some might charge a download fee, whatever. You say, okay, I want to use this model, and the model has enough metadata that it says what kind of inputs it needs. So you say click the model. It says, okay, here are the possible input data sets which are compatible with this model. Yeah. So there's enough. You need enough metadata to be able to work that out. But here's the possible input data sets, and here's the possible training parameters. So let's say you want to customize the model. If you want to do some additional training to create your own variant of the model. Yeah, let's say a special purpose model. And then maybe there might be a compute provider that says, okay, well, I will run this training process for you on a distributed set of machines, and I'll just give you back the result, the model which comes out of that training process. And you can say, okay, so you could literally just drag and drop the components that you want to create your own custom AI model. When you've got your model, you can say, okay, now I want to deploy this to users of my app. Well, this is fantastic because you just put it on the data lattice, and then any app can just pull from the data lattice to get the latest version of the model. And obviously you can check on the hash that it was one that you've authenticated and said this is the official latest version of the model. So you could have the entire supply chain from different data sources, different data cleaning processes, different participants in the supply chain, and you just orchestrate that and manage that and pull together the bits you need in order to build a model, and then you deploy it, and then your app is using that model basically from the data lattice. So treating the data lattice really as a content distribution network, which is another thing you can use the data lattice for. So you can do this thing end to end pretty much using this kind of tech. Now I say end to end, it's managing the supply chain end to end. Obviously people within that components of that might use centralized hardware. Yeah, so a person doing model training on a big distributed set of GPUs, they're going to use some centralized resource, some centralized infrastructure to do all of that. But the result would still be authenticated. Yeah, you'd still have a signature. You'd still have a hash that you could validate the result against. And theoretically, if it's a reproducible run, so no randomness, you could get someone else to do the same training process and prove that you actually come up with the same model at the end. So these entire supply chains could just be orchestrated like that, and you could have an app that enables to be able to do that. Now it's quite a bit of building to get to that point, but it's certainly there's nothing in there that's magic. Yeah, this is all all just known engineering, I would say at this point.
Okay, then let's mix up a bag, and in this bag we have this capability. But one of the big use cases for decentralized tech is non-fungible tokens. And non-fungible tokens, they say, can really help supply chains. So how would we interject NFT technology into this equation?
I mean, it's an interesting.
And would it be necessary at all?
It wouldn't be necessary. Could you find a use for it? Maybe. So the copyright of a particular, allowing that copyright law is complicated. Yeah, but the copyright ownership of a particular data asset, to the extent that copyright law recognises that, could be a tradable NFT. So you're the first person who registers an asset with this particular hash. You then say, okay, I'd like to make this asset tradable, so I'm going to sell my copyright rights. So I'm going to wrap that asset hash in an NFT, and I'm going to then basically say to people, hey, this is the legal ownership of this data asset. Or at least my copyright rights to this data asset, and that's for sale. Now, I say it gets complicated because a data asset can potentially have multiple parties with copyright claims on various aspects of it.
Right.
Yeah.
Right.
So it wouldn't necessarily guarantee ownership of the NFT doesn't guarantee you're completely clear of legal issues. Yeah, you might buy the asset thinking that you had the full copyright, but in fact they've used some stolen data in the model somewhere, and you then might have a copyright infringement claim against you for using it. So it doesn't solve the mess in the legal system, but it would be a tradable digital asset in the sense that a digital version of selling some IP, yeah. So from the trading and economic aspect, it would be a full ownership right, or represent a full ownership right. So that's how I see NFTs coming in, and it kind of makes sense because, like, if you have IP ownership of a particular data asset, nobody else should have that IP ownership of that same data asset, yeah? Because if you've got the same hash, you must have produced the same thing, and that's, more or less implausible that two people would independently create the same large work.
Right.
Or if they've done the same thing, then what they've done probably wasn't a creative step in the first place. Yeah, it's probably just pressing down on something.
But if it was an important piece of data, then fractionalization of an NFT could help, like either support the creation of that data, or say I wanted a certain bit of data, and I had an NFT and I fractionalized it in order to either fund the creation of that data, or once that data was available, monetize that by fractionalizing it. And is there a play there that you can?
Yep. Yeah. So that would be like, I would distinguish very carefully between, I mean, an NFT itself can't really be fractionalized. It is a unique entity, but you could split up the revenue stream associated with that IP.
Yeah.
So you could say, well, look, whatever royalties this IP earns in the future go through this smart contract, and it will then distribute those royalties according to what royalty shares owned by different parties. And those royalty shares would be a fungible token. Yeah. So you've got a non-fungible token that represents the IP, and then fungible tokens that represent shares of the revenue arising from that IP. I mean, it's going to get complicated when you start doing things like bundling IPs together or selling half of your IP. You know, and you then, how do you then reallocate the revenue shares? But I mean, that's just a matter for contract. Yeah. So you'd have to solve that in the real world. You have to solve it in the digital world as well. I don't think that's any different, but at least theoretically, it's a pretty clean mapping. Yeah. So the IP is an NFT, and the revenue shares are a fungible token. And when I say IP, the IP could be a data set or it could be a model. Yeah, they're sort of interchangeable in this sense. So if you build a model, you've got IP in the model. If you build a data set, you've got IP in the data. And copyright law, of course, is complicated. So if you compile a database, you might not have copyright on the individual items in the database, but you might have copyright over the work as a whole.
Right.
So this is where it does get very complicated. Yeah. So you might have you might have, because you've gone to effort in compiling and putting together that data set. So there is work and skill involved in doing that, and copyright law does recognise that, I think, at least in most jurisdictions.
I wonder if that's an argument for like all the artists who are complaining that their work is being monetized through AI. They actually are compiled with a bunch of other artists in this model that says, okay, make it like this, and it happens to pull somebody's art style. I wonder if they have an argument there legally to say, well, no, we compiled all of these different artists. We don't claim copyright over that particular art, but over this compilation of 30 different artists who you can kind of mix and match. I wonder if they have a claim.
They would definitely. I mean, I think under most emerging laws. So in current copyright law, they'd have a claim against the composite work. Yeah. If it was being used without their permission. So it would, unless it was fair use. If it's fair use, you're okay. But if you're including someone's work verbatim inside a compilation of other works, then that would be beyond fair use. So you'd have to get a license, or you'd potentially be in violation of copyright law. Now, the big legal question at the moment is if you use that data set to create a model, where the model itself does not actually contain the copyrighted work, but was trained on the copyrighted work, what does that mean? And this is a super complicated one, yeah, because it is possible. A really important idea in AI is overfitting. Yeah, you can overfit a model to some data, and what it does is it just reproduces that data automatically. Yeah. So if you overfitted a model on the complete works of Shakespeare, and you said, generate me a book, it would generate the complete works of Shakespeare. So effectively the model is just remembered all of that work. Right? So it's not learned how to write like Shakespeare, it's learned how to write exactly the complete works of Shakespeare. Yeah? Which is less clever than Shakespeare, yeah? Because you can do that with a photocopier. But you can, an overfitted model basically just reproduces what it was trained on. And this is a common thing that happens when training AI models, and there's quite a lot of evidence that things like ChatGPT and some of these image generation models are strongly overfitting on certain inputs and certain sources. I think there was an article about the New York Times had some claims against reproduction of their articles. Yeah, so articles that have been referenced a lot, quoted a lot, and the model basically would reproduce chunks of text from these articles. I think it was the New York Times, and I think they filed a lawsuit about that a couple of months ago.
Yeah, I seem to remember that. Yeah, it wasn't too long ago.
Yeah, but that's pretty strong evidence of overfitting. And you say, well, an overfitted model is really just a different way of formatting the same data. Yeah, it's just memorized that data, and it's just reproducing it. And then you can go, well, that's not actually gone through a creative step. You're just reproducing someone else's work, and that's copying. So that's copyright. But then there's this big the problem is then there's this big grey area, and the grey area is, let's say you've learned how to paint in the style of certain painters, but you're still creating original work. Yeah, so your image generation models, for example, so it will do paintings in the style of Picasso, but not exactly Picasso's existing paintings. Yeah.
Right.
Go, well, it's absorbed aspects about Picasso's style, but it is still doing novel, new things. It's creating things through, some kind of, stable diffusion kind of process or something like that, which is creating randomness, and it's creating interesting new variations and combinations of different ideas. And you can go, well, is that copying? No, it's not direct copying. Does it draw from inspiration from the underlying thing? Well, yes, it does. Should that be covered by copyright? That's the big regulatory question at the moment. Yeah. The traditional copyright law doesn't really have an answer to that, because what do? Yeah, we read books, we read articles, and we write, and we're drawing on inspiration of all the things we've read throughout our life. Now, does that mean that we're copying? No. Yeah, we've applied a thought process and a creative process and come up with our own words, hopefully. When a human does it, it definitely isn't covered by copyright. Yeah, you can learn from things and then write your own thing, and there's no copyright claim against you for having read Tolkien's The Lord of the Rings if you write your own your own new fantasy story. But when an AI model does that, should that be covered by copyright? And this is where one of the critical debates is. Now, I think back to the crypto link, I think crypto won't answer that question, but it can facilitate resolution, by which I mean you can be very specific about exactly what was used, and exactly what contracts were made, exactly what rights were sold, exactly what revenue share goes to who. All of this crypto can help with on the economic side. Yeah, doesn't necessarily settle the legal and regulatory questions, but whatever answers happens on the legal and regulatory side, you're still going to need provenance. Yeah, you're going to need to prove that you didn't do X or that you did do Y. Yeah, and that's where the data lattice, the crypto integrity becomes, and the crypto provenance becomes super important. That's where I think the real value is on the crypto side. Yeah, is the provenance and the ability to take those assets into the economic space. Monetary rewards, royalties, trading of IP, all of these kind of things. I think
I kind of had a question around. I know that with the data lattice, one of the things that we need to build out is like APIs around all of the that to get that working. I was kind of curious. Aman is helping us with some dev relationship stuff. I wonder, Aman, if you can speak. How would you see us engaging some developers to work on some different pieces of things that we've identified are needed? If you don't answer, somebody else is gonna.
Tough question to just drop on the poor guy like
that. Well, he's got his hand up, right? He's perpetually has his hand up.
his photo's got a hand up, which is nice. I think it's a wave. Maybe just change
well,
the screen. So
I know we've talked about hackathons and stuff, so that's also one of the ways that we can engage folks like that.
Yeah, I mean, there's a lot of very interesting stuff, hacking stuff to do, and I think you know, we really will be focusing on building the infrastructure that makes all of this possible, but then it just creates an incredible opportunity for innovating on top on the data lattice and on convex for the economic side. So you know, we're all about trying to open up opportunities for people in the ecosystem ultimately, and I think this is a super exciting space. Good question on the YouTube chat, by the way. What might be a charging mechanism for AI queries? Can we pay with cryptocurrency? So this is a sort of super good question. I mean, there's lots of potential business models. I mean, some of these things have a subscription-based model. Yeah. So you could have buy a subscription to a particular AI service, and you get, you know, so many thousand queries a month, or whatever the model is. So I think things like Midjourney do a subscription-based model, subscription-based pricing. Another option would be to sort of have like a pay-as-you-go model where you can buy some credits. So you could have AI query credits and say, I'd like to buy, you know, $20 worth of AI query credits, and then those credits can be used as and when you want. You know, you can keep them, you can use them, you can buy more if you want, or if you don't need them, you know, you can sell them. So that would be quite a good option. I quite like that option. I quite like the idea of using fungible tokens as like a prepayment tool, because it's quite a natural utility token. Yeah, the utility is obviously being able to get AI queries answered. So I think that would probably be my preferred model. So I feel like a prepayment token that is tradable, and you can use to pay for the particular queries. You could, of course, pay with a stable coin. Yeah, that's the other option. So you know, buy your queries directly, micropayments with a stable coin. That's also a perfectly reasonable option. I think probably you want a prepay model, because you don't really want to be signing a purchase transaction every time you do a query. You're more likely to want to buy enough credit to do 100 queries and not worry about signing a transaction every single time you do a query. But I mean, that's obviously a product design question. But you know, I suspect credits are probably a better way of doing it than pay on every single query. But you could say, you know, have an order for every single query. Any other charging mechanisms that might be interesting? I think there's an interesting one is, could you sort of reverse auction it as well? So could you say, here's the query I want to run, and this is probably more relevant for stuff like where there's a lot of infrastructure required. So it's probably less of an AI query, more of a model training thing. But you could say, this is the data set I want to use. This is the algorithm I want to use to train the model. I'd like someone to produce a trained model for me. And you say, okay, well, you get people to bid. You know, how much will they charge to run that training process for you? And then the lowest bid can win, or can win the deal. They have to produce the result model within 24 hours or whatever the training time window is meant to be. and then the result will be a hash of a data which you download and verify, and hopefully they've done their job right. It's a working trained model. Obviously there is some degree of trust in that, yeah, because someone could take the money and just give a random empty file at the end, and you've not done any training at all. So you'd have to have a way of validating and not paying if the person cheated. But that probably can be worked out with a reputation system or something like that. So that'd be a way of incentivizing infrastructure providers to run jobs and AI tasks. I think model training is probably the most obvious use of that, because they're big jobs and require a lot of infrastructure. But that could definitely be done with cryptocurrency based payments, and indeed smart contracts. You have a smart contract that basically just mediates those transactions. So that might be an interesting one. I think crypto is quite good for incentivizing infrastructure provision, providing you can make a very clear standard of how you specify the job, yeah, because people would have to be able to automate these jobs. So they'd have to be able to say, this is what I'm doing, this is the input data. They'd have to be able to automate all of that in order for it to be an efficient process. So yeah, that needs a protocol. That would need I do know a couple of protocols that do that, or something very close to that, but it's quite hard to get right. That's the tricky bit there.
That sounds like all we got time for.
Yeah, it's a great conversation, a lot of interesting topics, and obviously a very exciting space. So super excited to get some good demos and projects on the AI space running on Convex very soon.
Yeah. Thanks, Mike. Thanks everybody.
Thanks everyone for joining. Thanks for all the great questions. See you all soon.